Okay, so here we are in 5.7. Question number 4. Find the amount that results from the given investment. Okay, so did you guys, did we see both formulas last time? I can't remember. Just one? Just one. Okay, well, here comes the second one. Here's the phrase compounded continuously. Compounded continuously. So when they do that, you need a special formula when they say compounded continuously. And I call it the PERT formula. A equals PE to the RT. So RT is up in the power zone. And this is for continuous compounding. For continuous compounding. So for continuous compounding, there's the formula we use. For all the other, so maybe I should write the other one too at the same time, be helpful. For any other compounding, so that would be monthly, daily, quarterly, annually, all the other ones, we use the formula A equals P 1 plus, one we just used on the quiz, to the NT, right? And I'll give you both these formulas at the top of exam 3. Don't even need to put them on a 3x5 card. They'll be right on the first page, right at the top of exam number 3. Well, that one's going off the screen today, huh? Okay, it's limiting my space. Let me squeeze it over a little bit. You already know that one anyway. Okay, yeah. So, yeah, those are the two formulas. The whole section is about those two formulas. We're just going to keep using those two formulas again and again and again. How do you know which one? If it's continuous compounding, use the PERT. Any other kind of compounding, use the first one. Yeah?
When I was doing the homework, I noticed for the first one,
Uh-huh.
I had the continuous compounding, I put 365 for the end. And sometimes it worked and sometimes it wasn't. I was wondering why.
For continuous, you use the first formula and put in 365 for n? Yeah, because that's almost continuous. Because that's every day. So every day compounding is close. So if they don't have you round too far, then the answer might come out the same. It's close to continuous. Yeah, so that'd be why. Yeah, but so really you're supposed to use the PERT, but they'll come out pretty close. The PERT will be exactly right. All right, so continuous compounding, we'll use the PERT one. Here we go. $60 is invested. Where does the 60 go? That's the P, principal investment. E is just that special number. By the way, this is where E came from. Comes from, everyone like, what is that number E? You're almost ready to see calculus, you can really prove it. But E came from continuous compounding. So you guys understand the idea of continuous? Well, here, let me first put in the R. 0.09 is my R, 9%, right? T, 2 years. Everybody good there? See what I did? And then hit the buttons on the calculator. So this is going to be 60. The E is above the natural log, right? Hit second natural log. I'm getting $71.83. $71.83. $60 will grow to be $71.83 after 2 years. Continuously compounded at 9%.
Why do we put E over there?
What's that?
Is E just part of the formula?
Yeah, so good question. Where did E come from? E is a special number, kind of like pi is a special number. Where did it come from? Well, it's the idea of continuous. You guys get the feel of compounding. So like if they take your money and they compound it once a year, well then that's just once a year. If they compound it more often, then more frequent compounding. Let's get a little bit theoretical. It's probably worth a minute of our time or two, just to give you the big picture. If you have like 10, if somebody says, okay, we have this 10% account, and we're going to compound your money one time per year. Well, then that just means they'll give you 10% at the end of the year once. That's pretty simple. But what if they say, we're going to give you 10%, but we're going to compound it 2 times, semi-annually, twice a year? That, I don't know if you know, but that doesn't mean they're going to do 10%, 10%. They're going to do 5%, 5%. So total of 10%. done twice a year. That's what that actually means. Well, if a bank account says we're going to pay, or any kind of account says we're going to pay 10% compounded twice a year, they mean total 10%. So what they really do is 5% twice. Does that make sense? It doesn't mean 10% twice. So if they say, oh, okay, we're going to do 12% monthly. Well, what that means is they'll do 1% each month, 12 times. Right? So it's 12% total. But here's the deal. You might think, okay, 12%, 10% done twice, which means 5% actually each time. That's going to be the same as just doing 10% once. Not quite, actually. 5% twice will be a little better than 10% once. Why? Because the second 5% will have a little growth on it. Is that making any sense? Right? Think with me on that for just a second. If I was to take $100, okay, and let's do this. Let's just increase it by 10%. If you increase that by 10%, what does it become? What's $100 increased 10%? $110, right? We all good? Because $10 is 10% of 100. Okay. Now, what if I do, by way of comparison, $100 and I increase it 5% first, and then another 5%. So if I increase it 5%, it becomes $105, clearly, right? And then you say, okay, now I'll do another 5%, so it's 110. Well, no. Now you're taking 105 halfway through the year, right? 105, and you're increasing that 5%. You're not increasing the original 100 anymore. Now you've grown. So, well, how do you figure that out? Well, you take 0.05, right? 5% of 105. Figure out what that is. I don't know. You get a extra quarter. I think? Yeah, shiny quarter. Exactly. Yeah, 5.25. Right. So it goes up 5.25. So the final thing becomes it's $105, and then this increases another $5.25. So it becomes $110.25. So you get a shiny quarter more than the other account. But of course, we're only talking about $100. You put in millions of dollars, this matters to people. But anyway, see the difference. I'm just trying to mainly give you the math concept. You see the difference. 5% done twice is slightly better than 10% done once. Slightly, barely. In fact, let me ask this. What is the actual effect? Because that's what they determine all the time. In fact, there's laws that say when you take loans and invest in things, they've got to tell you the actual effect. So if they say, hey, we're going to do 10% one time a year. Well, that's 10%. I mean, nothing magic there. If you just do it once a year, that is the effect. But what's the effect? What's the effect of 5% twice? In other words, semi-annually. 5% twice. Well, $100, when all was said and done, became $110.25, didn't it? So what did it grow by? It grew by $10.25, didn't it? Right? Went from 100 to 110.25. It grew by $10.25. What percentage growth is that? Well, divide it by the original amount to see what part of it grew, right? You with me? So what is that? 10.25 divided by 100. Well, I don't need to divide by 100. Just move the decimal back 2 places. Why am I hitting buttons? Just move the decimal back 2 places. 0.1025. In other words, what percentage is that? 10.25%. The actual effect is 10.25%. In other words, 5% done twice is the same as 10.25% done once. That's the actual effect. Does everybody see that? We're going to actually use that concept in about 5 or 6 problems away. So I'm kind of preempting something. So does everybody get that idea? That's, by law, they have to tell you the actual effect. So if you take a loan or invest in something, and it says we're going to do 5% done twice, you might think 5%, that's just 10%. No, it's a little better than 10%. It's 10.25 as we see in this situation. That's the actual effect, whereas 10% done once is just 10%. See that difference? So now, what does it mean if you compound continuously? This is compounded twice. If you compound more often, you say, okay, I'm going to do the 10% thing, but I'm going to compound like daily, every day. Well, maybe I'm jumping too fast. We did. If you compound twice, 2 times, you compound twice, then that's taking 10% divided by 2, in other words, 5% 2 times, right? But if you compound 10% and you compound it like monthly, how would you do it monthly? You would take the 10% and you divide by 12. And then you do it 12 times. You take 1/12 of it and do it 12 times. Like for 10% done twice, they take half of it and do it twice. But it actually comes out a little better, doesn't it? You get it. I'm not into exact numbers right now. Well, I'll show you how to get the exact numbers in a minute. I just want to land into your mind the big idea. To get the big idea, the more frequently you compound, the larger is the actual effect. So if you take 10% and you just do it once in a year, that'll just be 10%. If you take 10%, you do it twice, which really means 5%, twice. Right? Because they'll list it at 10%. They'll say, this is a 10% account, compounded, semi-annually. And what they really mean is, you take the 10% and divide by 2 and do it twice. 5% twice. That's what they mean. But they'll list it at 10. They'll say, it is a 10%, done twice. And they mean 5. And the actual effect, like we calculated a minute ago, is 10.25%. Right? You with me? So what if they say 10% done, more and more often, like compounded daily? That's pretty often. What would it become? I don't know what the number is. Maybe it'd be 10.38. I'm just going to guess. But my point is it'd be a little higher than even the 10.25 that we got for the semi-annual. The effect, the actual result. Is everybody tracking with me? The more often you compound, the greater the actual effect. So, what's the most frequent kind of compounding? Continuously. What would 10%, well, that would come out even higher. I'm just guessing, maybe 10.41 or something. It's not crazy big, but a little higher. I'm just guessing. Those are probably too high, though. This is probably, whatever, they're probably too high. But do you get the idea, though? Continuous compounding. How do you do that? How do you actually continuously compound? Like, how often is that? Yeah, we already got it every day. Daily is one of our things. This is even more than that. Is it like every hour? More often than that, it's continuous. Every minute? More often than that, it's continuous. Every second? More often than that, it's continuous. You get the idea? Continuous is continuous. There's no break in it at all. Well, no, I'm not saying bankers actually sit around and bang, really fast. No, that's not what we're talking about. It's all just a calculation. But continuous compounding, you know what it is? It's a difference. See that clock in the wall? That clock is an analog clock or a digital clock as opposed to a continuous clock. What am I talking about? You know what I mean? Look at that red second hand.
One of the ones that goes slowly around always.
Yeah, its movement is not smooth. It's not continuous. It's jump, right? In other words, it only has 60 different positions it'll be in up there, that red second hand. Whereas the kind that goes smooth has an infinite number of positions it'll be there. That's the continuous clock, right? See the difference? That's called analog or digital. Digital means finite states, finite number of states, not infinite number of positions, right? So that's what we're talking about with continuous compounding. It's continuous growth, continuous compounding, not state. Now they can calculate it for money, but you know where it really is true in life? I mean, you can calculate it for money. But you know what really grows in the next section, which we'll do here in about an hour if I don't wax too eloquent here for too long. 5.8 in the next section, we're going to talk about biology. We're going to talk about the growth of insect populations and, E. coli and petri dish and stuff like that. Living things, their growth is continuous, right? You don't look at a baby and one day all of a sudden they jump up. That's just in the cartoons and stuff, right? Growth of a living thing is continuous, with continually, more cells are growing and all that, right? So that's where we for sure will use continuous, because that's where we see in real life continuous growth. All right, with all that said in mind, all right, so 500 invested at 12%, compounded continuously, 2 3/4 years. Give that a try. How do you know which of the two formulas to use? Continuously. Because it says continuously, right? So as soon as you see that, you go, okay, That's the PERT formula. Continuous growth. This is a big concept if you move up in math and science, is continuous things versus they're discrete. It's also called discrete or analog or digital things. What do you do for 2 3/4? 2.75, right? 3/4 of $1.75. 2.75. So plug into the PERT formula. The 500. What's the 500? That's the P. Oh, and so I was doing all that story to say that's how they came up with E. They were just measuring continuous growth. That's where they found the number E. Yeah, I forgot why I even went on that story. Somebody asked what E was. Yeah, sorry, I got lost in my own story. So that's where they came up with E. Now I can't mathematically show it to you until you've had calculus. You need Calc 1, and then you can actually derive it that way. Tim, your tutor, you know Tim? He does after he said, did he sit in a lecture yesterday? Tuesday? No, he sat in the other class. Anyway, I said it so that he went and derived it and came back and grabbed me in my office later, and he had done it correctly. He derived it. So they came up with E using calculus. They basically did continuous growth, and that's where they came up with that special number. It is the number representing continuous growth. They discovered it that way. All right, let's put in point 12. The time is 2.75. Hit the buttons on the calculator. 500 times E. I think Tim finds out today if he got into some big college. I mean, I know. He actually found out yesterday. And I wonder if he got it. Harvard, or he's applying to the big colleges, Brown, those kind.
Yeah, but I don't think that's where he wants to go.
He told me yesterday his first choice would be Brown.
Oh, he would go to Brown?
Yeah, he wants to go to Brown. Yeah, he got into Poly already. He told me.
There's another one, though. There was one other one. I can't remember, but he said he really liked to go to.
Yeah.
Did do a lot of research there, he said that he liked, but I can't remember.
Yeah.
Has a different name.
Yeah. Do you know if he got into the one he wanted? Yesterday he was supposed
You
to.
know, I didn't get a chance.
Wasn't it Harvard yesterday? Which is the one? Is it Harvard?
It might have been.
I can't remember which one it is. Find out yesterday. Yeah, I don't know. I don't know if he did. 695.48. Boom. Good?
Man.
All good? All right. We'll move on. So here we go. A equals. Now, which formula are we supposed to use here? Yeah, compounded monthly. So if it's continuous, that's the PERT. Anything else, it's the first formula. So I'll give you those two formulas right at the top of this. Don't need to memorize them. Try that one, plug in the information. To get 800, where's that 800 go? That's the A, isn't it? Because that's what you want to get. Make sense? That's the amount. You want to, remember, P is the principal you put in the bank now. A is the amount coming out later. That's the amount you want to get. Interest rate is 7%. What's the N? Yeah, compounding monthly. N is 12 for monthly, right? And it's for 3 years. So there we go. How do we solve that for P? Yeah, we got to divide by that whole big chunk, don't we? Everybody see that? We got to divide by this whole 1 plus 0.07. So that's to the 30. I was going to make that 36 power, huh? What do to one side, do to the other? Boom. That good? Like that? How are we doing? Am I losing you?
The one on number 6, I went to it, they gave us something else, like a different type of formula.
Yeah, they probably just took this and solved for P.
Yeah.
And they made it a negative power, didn't they? They have negative power.
Can we do it that way?
You can, sure. That'll work fine.
Okay.
Honestly, I wouldn't suggest it because I'm going to give you these on the test. But if you want to write other formulas down your 2x5 card, you could.
Okay.
Whatever works for you. So yeah, so we got to calculate this right here. Like this, right? We good? Now, let me show you a way to make that easy on the calculator. It's easiest to use to just start with this inside right here. So here's how I would do it on the calculator. I would start with the here, let me write it up here. 800, oh, it's off the screen, huh? Darn that screen today. It is shifted. So on the calculator, the 800 over 1 plus 0.07 over 12 to the 36. Here's what I would actually do on the calculator. First I would go 1 plus 0.07 divided by 12, and then just hit enter. I just start in the bottom with the messiest part. This will make it easier. This way you won't have to worry about parentheses, because what messes people up is all the parentheses and all that stuff. So I would just start with this part right in here. 1 plus 0.07 divided by 12, enter. And then go to the power 36, enter. It'll know that you mean the last answer. It'll automatically grab the words answer. When you just go to the power 36, it says, oh, your last answer? Yeah, that's the one I want. To the 36. Now we've done the whole denominator, right? And then you just type in 800 divided by, and then you hit second answer. Do you know where the answer button is? It means the last answer on my screen. It's down at the very bottom of your calculator above the negative. Hit second answer and then enter. That's the easy way to calculate that whole thing. So, to the power 36, 800. I'm getting 648.86. 648. Hey, that way you don't have to worry about parentheses and stuff. There we go.
What was the back part of this one?
What's that?
What's the back part of using this one?
You have another formula to memorize and put in your card. You got to remember when to use it and when to use the other one. Whereas this is just boom, same formula every time. That's how I work better. I work better with just one formula all the time. But good there. Yeah, the Math Excel Show Me Help button presents a different formula. That's what they do. Anyway, either way, it's fine. All right, we good? Better. Okay, so effective rate. So look at the listed rate, 5.25% compounded quarterly. That's the listed rate. So what do they mean by that? What's a quarter? What decimal? 5.25 is 5.25%. Okay, so that's what they're listing. That's what they're saying. But really, the effect is going to be higher, isn't it? You with me? So remember, this is the big picture idea that I was talking about a few minutes ago. So now we're here to an actual calculation. They want us to figure out, okay, they're saying 5.25%, but they're compounding your money quarterly, 4 times a year. So it's actually going to come out a little better than 5.25. What's the real effect going to be? That's where they pass laws that they have to study the real effect and all that. So how do you calculate that? Bless you. How do you calculate the real effect? Well, let me give you some steps. This is my own little thing. Math Excel does something different. In fact, they used to do something crazy. I don't know if they still do. Step 1, P equals $1 for T equals 1 year. P equals $1 for T equals 1 year. In other words, here's my thinking. I'm thinking, look, if I want to figure out what an account is actually doing, then just find out what happens to $1 after 1 year. Just find out what happens to $1 after 1 year, and then you'll know the effect. You know what I mean? Am I making any sense? But if I say, hey, I took this account, I put $1 in, and it became $1.07 after a year. Well, okay, so how much did my money grow by? 7 cents, another 7%. That's the effect. Whatever they called it, whatever. The real effect Well, 7%. You know what I mean? If I can find out what happens to $1, I can find out what happens to every dollar. I can find the real effect of the account. So that's my plan. Math Excel does something very different. It's also called, by the way, APY out there in the world, annual percentage yield. Same thing, effective rate. Meaning, what's the actual, annual means, at the end of the year. Annual percentage yield. What does it yield? What is it the effect? What is the produce of it? What's the product? All right, so do that, and then take your answer and subtract the original dollar. Do you know what I mean? Like if the $1, like I said just a minute ago, became $1.07, then I would need to subtract the original dollar and say, here's the actual growth, 0.07. Right? Because the original dollar is not growth. That was already there. We just want to know the growth, the effect of the growth. So subtract the original dollar. Okay, that's it. That's all you do. So same. I'm not going to use a new formula. Same two formulas. It's just put in $1 for 1 year. P is 1, T is 1. So which formula am I using? The first one or the PERT one? Compounded quarterly. It's not continuous. That's the only time we use PERT is continuous. So we use the first formula. Am I on the screen? Barely? Okay. And we put in $1, P is 1. The rate, the listed rate, is 5.25, so make that 0.0525 when you make that a decimal. The N, am I going too quick? What's the N? 4, huh? 4 times a year. And the T, what's the T? Well, we're putting in 1 year, right? Because we want to know the effect in 1 year. $1, 1 year. See how I put in P is 1, T is 1. Everybody see that? I want to know what happens to $1 after 1 year. Then I'll know the effect, the real effect of this account. It's going to be something a little higher than 5.25. That's what they're saying it is, but it's really a little better. All right, calculate it. Hit the buttons. I'm getting 1.0535426667. And then you got to just get rid of that 1 in the front, huh? Subtract the original $1 because that was already there, the $1. I just want the amount it increased by. So it's 0.0535426667. And then that's a decimal answer. We have to change that back to percentage. How do you change a decimal to percentage? 2 places. Comes up right here. So how many they want? 3. 5.354%. There it is. 5.354%. That's the actual effect of that account. It's not really 5.25, it's a little better than that. It's really 5.354. Is that all coming out okay? Any questions on that? So there's for sure one of these on the exam. Effective rate, and Math Excel does it. They do, if I remember right, if you show me example, they do something crazy, I think. All right, let's try one of these. So here it is. It says find effective rate. 3% compounded continuously. Oh, okay. So try that with 3% compounded continuously. So which formula are we going to use? The PERT one, right? Because this is continuous compounding.
It says continuously.
How is it? What do you got? Something good? No?
Oh, no. You said PERT.
PERT. There it is. A equals P e to the RT. And that's because of continuous, right? The Effective rate. What do you always do for effective rate? So you want to really remember it. I mean, it says you want to put that on your 3x5 card. There will be an effective rate question on the exam. Effective rate, $1 1 year, right? Find the effect on $1 for 1 year. What's going to happen to $1 after 1 year? So I'm going to put in $1. The rate is stated to be 3%, but we know in reality it'll be higher. So figure that out. I'm getting 1.03045. So get rid of that 1 in the front. That's the growth. Good. Move the decimal 2 places to make it back into a percentage. 3.045%. 3 places. 3.045. So that's the actual effect. 3% done continuously is really 3.045%. That's the real effect. That's what will really happen to your money. Every dollar will grow by that amount. Or if you're borrowing money, you'll owe that amount for every dollar. Is that good? Questions on that? We okay? So always remember that effective rate, $1 1 year. So number 13. Which of the two rates would yield the larger amount in 1 year? 5% quarterly or 5 1/4 annually. So how do you compare two things and know which one's really better? Say, okay, you can invest this one account, it's 5%, but we do it quarterly. The other one is 5 1/4%, a little higher, but we do it not as often, annually. Notice that, right? It says higher, but it's done only once a year, annually, like a birthday or something, once a year, right? You celebrate your birthday annually, once a year, right? You don't celebrate it quarterly, do you? 4 times a year. You'd be getting pretty old by now. All right, so 5%. So this is lower, but it's done more often. And this is higher, but it's done less often. How do you know which one's really better? You've got to find the effective rate. They're not saying it, but that's what you got to do. So whenever you want to compare things, you need to figure out effective rates. So comparing, to compare, find effective rates for both. Does that make sense? So whenever they give you these questions about comparing two accounts, what you have to do is find the effective rate for both. Effective rate for both. Okay, so let's do the first one. 5 1/4% compounded annually. So that's 5.25% compounded annually. You with me so far? I want to find the effective rate of that. What's really going to happen in 1 year with that account? Any thoughts? How about that first one? What's going to happen in 1 year? Do you realize I don't need to do anything? That's what's going to happen in 1 year. Part A, there's nothing to do. Part B, we got to do. Part A's done. If you're only compounding the money once in a year, well then that's it. That's the effect. You see, it's only necessary to calculate it if they do it more than once. That's when it starts to change and morph. Right? You with me? So for annual compounding already is that on the screen? Is the effective rate. So if they're listing annual compounding, because that just means once a year, right? Like a birthday. They're just saying, hey, once a year annually, we're going to pay you 5.25%. So what's the effect for 1 year? Well, that's it. That's what they're doing in 1 year. 5.25. No mystery there. But for the other parts, we have to calculate. Like for part B, it says, okay, 5%, so that's part A. Down here, part B, 5% compounded quarterly. Now that's going to come out different. That's not just 5% done once. That's 5%, but you break it up over 4 little chunks. So that's going to come out something a little higher than 5%. Let's figure it out. What do? We put in $1 for 1 year. We find the effective rate. Equals, so effective rate calculation. So use A equals P. I'm going to use the first formula, right? It's not continuous. So I'm not using the PERT. It's not continuous. So I put in $1. Is that on the screen still? Okay. So I'm going to put in $1. And the rate, listed rate is 5%. Done 4 times a year for 1 year. You with me? Want to calculate that? Let's see what we get. I'm getting 1.0509. Am I on the screen? Oh, I'm off the screen. So get rid of the 1, move the decimal 2 places. 5.0945%. That's the real effect. It does 5.09. That's what it really does. 5% done in small chunks 4 times a year actually comes out 5.0945. So is that better or is the other one better? Yeah, 5.25 is still way higher. So we choose that one. Does that make sense? See how to compare? That's why it's the law that they have to give you effective rates on loans and investments so you know exactly what's really going to happen.
He's going to ask.
Yeah,
That's the trick when you don't ask. They don't have to tell you up front.
I think it has to be in the contract. I think. I don't know. I've checked the
They
law.
probably put it in the friendly.
Probably. They can trick you. Yeah, you know who's really bad is the payday loan places. You know, that's highway robbery. It's illegal in like 17 states. Payday loan places, yeah. Yeah. I always mean, maybe I finally have a little bit of time. Baseball's over this weekend. Because I always want to get the stats. I always want to give you the stats. Yeah, they're killing people financially. But I want to be able to give hard, cold numbers, not just make a statement like that. So anyway, maybe this weekend I'll research and get some extra numbers and bring it to you. But yeah, the payday loan places, which you see popping up all over town, that's virtually highway robbery. It's illegal in like 17 states because they're killing you financially. Yeah.
I've heard it's like 300% annually.
Yeah, I'll have to check out the numbers. Yeah, it's crazy because what it's something like that. You're right because you think no. I saw them. They say 10% or whatever. Yeah, but it's 10% for like 2 weeks. In other words, if you go to the bank and you borrow money or borrow buy a car and get a car loan, whatever, you must say I got 8%, 9%, 10%, whatever. Okay, yeah, but that's for a year. That's a year. Notice they'll let you use their money for a whole year, and then they'll pay you if you pay them 8% of whatever it was. That's a year. That's a normal loan. It's a year. These payday loan places, they'll give you the same kind of rate, but it's only for 2 weeks or 1 month till your next paycheck. So they're gouging you in reality. That's a crazy rate for that much. And then they get people hooked on that. They come back every month. And I had a buddy. He was just in that cycle. And because then he comes up short on his paycheck, goes in there, gets the paycheck early. They charge him that 10%. Guess what happens next month? Because they just took a chunk. Comes up short again. Goes in there. Pretty much that's his lifestyle. So he's just given whatever, 10% of his paycheck always to these scoundrels, right? That are popping up all over town. Like I said, it's illegal in I think 17 states. I'll try to get the facts. I like to have exact facts. I'll try to get you exact facts. I think it's interesting. Anyway, so effective rates, there it is. Okay, so to double an investment in 2 years. All right, so first off, which formula are we going to use? The first one or the PERT one?
The first one.
Yeah, because compounded annually, it's not continuous. So first formula again. Okay. Now, this one's a little different. What are we trying to do? We're trying to double our money. Double our money. How long to double our money? How are we going to do that? Double, what's that? We don't even know what they put in the bank. Good. You just simply put in the A slot 2P. Exactly. We don't know what the principal is, but you want the amount later to be double whatever the P was, whatever the principal investment was. Does that make sense? And the rate's what we're trying to find. What's the N? Yeah, annually, once a year, huh? And the T, 2 years, they said right here. So far, so good. Not making sense? So the amount is twice the principal. It's twice the principal investment. Right? Because the P is the principal investment. Common mistake I see, well, here, let me show you the right thing and then I'll... So how would we now solve this? What's our first step? We don't want two letters. See how we have P and R? We don't want that. We can only handle one letter at a time. But what's the first step going to be? Bye-bye, P. Right? So it'll be 2 equals 1 plus R to the 2. Everybody see that? R over 1. R over 1 is just R. Everybody see what happened? I just divided the P out of both sides. Now, common mistake I've seen over the years teaching this material is students will kind of half remember that the left side, and they'll just put a 2 instead of 2P, and then they'll get messed up. They'll get stuck because then they'll go, oh no, I got P and I got R, I got 2 letters, I don't know how to get rid of them, and they'll just get stuck and they won't be able to finish the problem. Remember, it's not just 2, it's 2 times the principal, isn't it? It's 2 times the original investment. Does that make sense? A 2 alone would be meaningless. It'd be like me saying, hey guys, double. You guys would go, double what? Right, you got to double something, huh? So it's double P. It's not, there's no such thing as just double alone, right? It's double P. It's double the principal investment. So don't forget the P there. So then, because then the P divides out on both sides, which is really nice. Get down to here. Okay, so 2 equals 1 plus R squared on the screen. Yeah. All right, now how do I solve for R? Yeah, you could just square root, couldn't you? Just square root it. Now, what if that was a weird power? What if that was like a 7th power or something? What would I do? 1/7 or 7th root on both sides, right? So whenever you have a number up in the power zone, you can just raise the power to 1 over that number, right? So you have 7, you can do 1/7 power on both sides. If you have a 2, you can do half power on both sides, which is the same thing as a square root. So root or fraction power. What if we had a letter? In a minute, they're going to give us like the T is going to be up here.
1 over T.
Then, well, the problem with doing 1 over T on both sides is you'd end up with the T over there. Also, that would mess you up. In that case, that's Hitler climbed into power. Letter in power, that's when you got to do ln of both sides. We'll get to all that in a minute. Let me just set that idea in your mind right now. 2 different kinds of problems they're going to give us. Numbers in the power, just do 1 over that. So I'll just go 1 over 2, 1 over 2. Or you can do square root, same thing. Cancels out. So 2 to the half is 1 plus. If you just have numbers up there, do that. If you have letters up there, ln both sides. That's the difference. We'll get to one of those in a minute. So then just subtract the 1 or just move the 1 over. So 2 to the half minus 1, that's R. That's a square root, same thing. Either way you want to do it. It is 0.414. What do they want here? 4142 135. That's R. They want me to move it 2 places. Put it right there. 41. 2.42%. There we go. 41.42%. Is that good? So if you found an account that's paying 41.42%, that's pretty impressive account. You would double your money in 2 years. Questions on that one? Yeah, Rudy. Oh, I didn't. I was. Did I confuse you by that?
Yeah.
That would be a different kind of problem when there's a T.
I know that, but I mean,
Oh.
this specific problem. Are you doing anything with
Oh, I put the 2 right here. Plugged it in for T. Right there. Yeah.
Could you do it when you square root it?
Yeah, so the half power is the same thing as the square root. Yeah, so if it bugs you the way I wrote it, feel free just to go square root on both sides. That's the same thing as a half power. So this is still just square root. It'll still come out the same. Same answer. Either way, half power is a square root. All right, so try that one. Triple an investment in 25 years. Which of the two formulas we're going to use? The first one or the PERT? Compounded annually, that's n equals 1. First formula, PERT's only for continuous. So triple, the amount is 3p, right? N is 1, 25 years. So first step to solve that thing. Divide off that p. We good to there? Okay, so there's two things you want to be really clear in your mind. Let me help with that. So number in the power, you do 1 over number on both sides. Is that on the screen? Yeah. And if you have letter in power, you do ln of both sides. Everybody okay on those two? Because they're gonna give us both of them. So if you have a number in the power, like we have the 25, then you 1 over the number both sides. If you have a letter in power, that's ln, right? That's the Hitler in power, letter in power thing I'm trying to key your memory for. So I'm going to come in here and go, okay, 1 over 25, 1 over 25 cancels. Getting that okay? 1 plus r. And then just subtract that 1. 3 to the 1/25th minus 1. So whatever that may be. I'm getting point. I'll be off the screen there, huh? Yeah. 0.044924. Move the decimal 2 places right here. And we get what? 4.49%. Did y'all get that okay? 4.49%? Questions on that?
How are you doing it in your calculator? Because I know
Are you putting the parentheses when you raise it?
Yeah. Yeah, make sure when you do the 3 to the 1/25th, you go 3 to the 1 divided by 25, then close. That's not on the screen. You got to close off that parenthesis. 3 to the power 1/25. Close that parenthesis. All right, I better move on. Grab me later if you have calculator issues or other kind of issues on that. Main point, though, we're about to change gears. Remember, number in power, 1 over number both sides. Letter in power, L in both sides. Good thing to put on your 3x5 card. So you could be making that thing up, even though the exam's like 3 weeks away or whatever. You could be making that or put a note on your notes. You have 3x5 card. Boom, boom. Those two facts are all right. All right. Let's see. Okay. So here we go, number 17. Let's try that one. It's similar, but a little different. We're bringing the curveball here. bailed out and it was right in the strike zone. Yeah. It's crazy. I watched junior high baseball this week. 2 games. Yeah.
What school?
My son played for Fresno Christian and they're playing Wawona. They played the little Division 6 championship yesterday in Wawona.
Really?
But no, winner, boom, it's over. Yeah.
Like Canada's just started.
Yeah, we're a little Division 6 league.
Oh, yeah, so they started already.
Or maybe junior high when we start early? I don't know. Yeah, junior high just started before high school, yeah. Fresno Christian in the little Division 6 league. But yeah, Matthew would be like 2 strike. You know, I feel like, don't the boys realize the pitcher, fastball, foul it off. And I would yell out from the stands with 2 strikes, especially when my son was out. Watch the curve, 2 strikes, you know what's coming. I mean, and they'd still be like, like, don't you know? And not everybody here know a curveball's coming now. I mean, I would even yell it out. Pitcher heard me say, curveball, here it comes. The junior high mentality, they're not realizing everything. All right, so so we're gonna do this one's got an extra trick. We're gonna do which formula do we use? The first one or the part one? There's 2 parts to this question, huh? For this one, it's compounded quarterly, so that's n is 4. Use the first one. 1 plus r over n to the n2, like that. Okay. And 9% compounded quarterly. So the amount in the principal, what are we going to do? Double in value. So what's the amount? 2p, right? The amount is 2p. The interest rate, 9%, 4 times a year. Okay, we good to there? Am I going too quick? Does that make sense to there? So doubling, 2p. All right, what's my first step? Divide out p. And everybody saw it compounds quarterly, so n is 4, right? So yeah, divide out the p. Gonzo. 2 equals 1 plus 0.09 over 4 to the 4t. We get to there. Now, what am I going to do? Everybody good? Everybody with me to here? So I really want you to see this step. This is like me yelling out, "Curveball's coming." So what's about to happen now? What do I need to do? Where's my what's in the power zone? Letter. So what do I do? ln of both sides. Everybody see the difference between this one and the last one? I just had a number in the power zone, no letter, so I just do 1 over the number. But if you have a letter up there, you got to ln both sides because that brings the power down, doesn't it? So what do we got then? ln 2 is 4t ln of 1 plus 0.09 over 4. Pretty good to there. And now we can just divide by all that stuff. We can just divide by the 4 and the ln of 1 plus 0.09 over 4. Just boom. Boom. Just get rid of them all at once. Both sides. 4 ln. Whoops, I'm probably running out of room here, aren't I? Just using up my screen today. I don't have room. So we're dividing both sides by 4 and ln 1 plus 0.09 over 4. 4 ln 1 plus 0.09 over 4. So I'm dividing both sides. And so there's my answer. I just got to type it into the calculator now. This is my answer right here. So when you type that in here, let me rewrite it a little cleaner. ln 2 over 4 ln 1 plus 0.09 over 4. When you type that into your calculator, what do you got to remember to do? Yeah, parentheses on the denominator. Or you could just start with the denominator and at the very end go ln 2 divided by answer. You won't have to worry about parentheses. I think that's easier. You know what I mean? I would just, if you don't want to worry about parentheses all the time, on your calculator you could just start with the bottom. 4 ln 1 plus 0.09 over 4. and then the next line, take ln2 divided by answer. That'll work fine. Either way. All right, so I'm getting 7.78795, blah, blah, blah. What do they say? Round 2 decimal places. So 7.79 years, just under 8 years. 7.79 years, this is years, is time, right? T. So just under 8 years to double your money at 9%. We good? Yeah, I'm not going to do that. Yeah, then they'd want you to do part 2 with continuous. You'd use the PERT formula. Everybody see that? Yeah. They over here they have part 2 where you use the PERT formula. Do the same thing again with the PERT formula. I'm going to move on. But yeah, same process. Everything's the same. Be even a little easier. Yeah. All right, so when the letter's up in the power zone, L in both sides. You just have a number up there, 1 over the number on both sides, right? Okay, what interest rate compounded quarterly? Effective rate of 9%. All right, how you doing? Let me let you try that one first off. That one has a trick. Give it a try. You can get more out of it if I give you a minute. So try that one. I'll wander around so I can help. I thought it was supposed to rain all week. Sorry, it's mine. I was really wanting my baseball game rain out. It's beautiful out there. That's true. It'd be great. All right, which formula are we going to use? The first one or the PERT? First. Yeah, because compounded quarterly, N is for, use the first one. Okay. See what you can do. This one is definitely a curveball. This is a tricky question. Yeah, right, because it's effective. Yeah, right. Is one correct. Yeah, it's effective rate, right? Remember what we do for effective rate? What do we always do when they say effective rate? See right here, effective rate. So effective rate. That's going to mean P is. You're saying what's going to happen to $1 in 1 year, right? Now you want to know the real effect, right? So to do this problem right, you really have to get it. Because this is going to be different. It's not hard, but it's different. It's a curveball, as I'm saying. You have to really understand. Not just, follow steps kind of blindly. You have to really get why we do what we do. If you get it, then you'll know just what to do. So, so think with me. Make sure you get the concept. Bless you. $1, 1 year, what's the effect? That's what we're doing with effective rate. Get the idea? If I say, hey, I put $1 in this account and it came out to be $1.09. What was the effect? It grew by 9%. Right? So if you find out what happens to $1 after 1 year, that's the effect. Well, what are they saying is the effect? 9%. That's exactly what they're saying. The effect is 9%. So guess what will happen to $1? What will it become after a year? If the effect is 9%, what will happen to my $1 after 1 year? That'll be the amount. You see? We haven't had to do this before. But does that make sense? And of course, P is 1. You always put in $1. And T is 1. N is 4, as we've already said. There's what we got to solve. Do you see how I came up with that? The actual effect. They're telling us the amount. They're saying, look, its effect was 9%. That's what it did. So that means the dollar became, the $1 I put in for principal became $1.09. That I know, because they told me the effective rate is 9%. Does that make sense? And they want me to find the listed rate, which will be something lower than 9%, like 8 something, which really becomes an effective 9% because of the compounding. Get that idea? So now we solve that for R. So 1.09 is 1 times 1 plus R over 4 to the 4. So what do? Do I have a... Can you finish it from there? Let me let you finish it from there. So how do I solve this thing for R? Do I have a number or a letter in the power zone? Number. So I just do 1 over the number, don't I? 1/4. 1/4 cancels it out. And so then what do we get? Let's bring it over here. We get 1.09 to the 1/4 is 1 plus R over 4. Y'all seeing that? Because the 4 and the 1/4 cancel each other out. Got to finish solving for R, so we just jump the 1 to the other side. And then what do we do to get R alone? Multiply both sides by 4. I'm running out of room here, aren't I? Bless you. So I multiply both sides by 4. That cancels that out. R is alone. It's 4 times 1.09 to the 1/4 minus 1. It's a messy problem. There we go. Wait, I'm not writing this very neatly. I'm losing my extra parentheses, aren't I? Okay, so what do we get? 1.09 to the 1/4. I'm getting 0.08771127. Change that to a percentage. 2 places. How many places at once? 2. 8.71%. That's the listed rate. 8.71%. The actual effect is 9%. So that makes sense, doesn't it? A lower, an 8.71, has an actual effect of 9%. How are we doing with all these financial things? You okay? Questions? All right. Very expensive. All right. So the average cost of college is $31,806 per year. What a deal, huh? 4 years is only $120,000. Craziness. All right. You know all this news that says all the time that the cost of college is going up way faster than inflation has been for the last 20 years or whatever. It's true, huh? So let's say that if it's $31,806 per year now, what will if it increases 7.2% each year, what will it be 13 years from now? Something crazy big. Something crazy big, huh? That's why junior college is a great solution, right? I believe in it myself. I went to junior college, My kids go to junior college. I mean, it's expensive. I got 2 kids in college, one at Fresno State, one at Cal Poly, and then the other one just got her little acceptance letter from Cal Poly. I'm like, good work, honey, but I don't think so. I mean, unless you want to take crazy loans. Anyway, all right, so let's figure it out. So how do we do it? It's just the same formula as usual. 1 plus r over n to the nt, like that. Okay. So plug the stuff in there. So the 31,000 is the P, because that's like the amount now. It's kind of like you're investing and it's going to grow, but it's a cost that we're talking about. Same thing though. It's really the same thing. So put in the 31,806. Right? That's the amount now. That's like the principal investment. What's it going to grow to become? Okay, the interest rate 7.2. See, it's probably right. Inflation's like 4%. Isn't that typically 4%? Something like that. So this is close to double. They say that it's close to double how college costs rise. 0.072 over n. What is n? Oh, n is going to be 1. Why is n 1 on this one? Because it says each year. That means once a year. 7.2% each year. So it's like compounding once a year. Once, like every year, up by 7. This is how you handle inflation. You can use this formula to calculate inflation on anything. So college costs or anything. So 7.2% each year means once a year. Once a year. So n is 1. And the time, 13 years. Same formula. See how that works? Hit the buttons. Let's find out how much college will cost on average 13 years from now. I'm getting, what a deal. $78,531.02 for each year of college on average, 13 years from now, if they continue to grow at the current rate. Yeah, some colleges already cost that much, huh? Usually they're medical schools or something, aren't they? They're that kind of price? I have a law school or something?
80,000 a year.
Yeah, 80,000 a year. Like that. Is that good? I mean, it's not good. But are you getting that answer? The union? Oh, just go to work, huh? Oh, yeah. Yeah, my wife, one daughter at Cal Poly, it's about 25, it's not 31, 25,000 a year, including room and board and everything.
That's not bad.
It's not, I mean, I think when I first started going to college, it was probably around 12 or 15.
Yeah, it's gone up a lot, huh? Yeah. I was talking to my buddy on the phone last week, or I think it was last week, who I went to Cal Poly with. I graduated in 93, so 25 years ago. Anyway, and I was telling him, Nick, my other daughter just got into Cal Poly. I can't afford to ship these kids to Cal Poly. And he's like, I can't either. You know, we're having the dad talk. Now we're dads, like this is craziness. And he's like, do you remember what it cost, Brett? Do you remember what it cost back when we went there? I'm like, I don't know, Nick. I don't remember anything. I have a terrible memory. I'm like, what did it cost? He said it was $3.50 a quarter, which means they do quarters at Cal Poly. So that'd be like about 3 quarters in a year. They do 3 quarters. So that'd be about $1,000. That's just tuition. That's not room and board. But still, that means about $1,000 a year tuition. Now, Cal Poly is about, Fresno State's about 8. Fresno State's about $8,000 a year. Cal Poly's about, 12 or 13.
Is that just tuition?
That's just tuition. Yeah, room and board and everything for my daughter's about 25. Yeah. So just tuition is 10, 11, 12, something like that.
For a year, though, right?
For a year. That's for a year. Yeah, for the academic year, not summer. But yeah, right. And Fresno State's 8. So it used to be 1,000. It's gone from 1,000 to 8 or 10 or 12, even just at state schools. These are state schools. This isn't private.
No.
Right? Which is craziness, yeah. Our little deal, I can't afford that. I'm one income, 5 kids, ain't gonna happen. That's why I told my daughter, So our deal is we'll pay for 2 years at Fresno State. Anything else you want, that's on you. And that's loans and that's pay. That's all I can afford. I mean, I think that's generous right there. So I believe in junior college. So my first daughter, she went to junior college, and now she's at Poly. So just 2 years at Poly. She's borrowing about $17,000 a year. So anyway, it's expensive. It's craziness. Very expensive. Fresno State is a great option. My kids are kind of snobbish. Well, my daughters. My son is a reasonable young man. He's fine with Fresno State. But my daughters think that they want to have an experience. I don't know. Whatever.
Because of the vacations to Pismo, so it did.
Yeah, I should have never gone to Pismo. Literally.